Alrighty, our objective in 9.1 is to identify those mathematical patterns way up there up top of the smartboard. Identify mathematical patterns found in a sequence, use a formula, whether or not it's explicit with n or it's recursive with a sub n minus 1. We want to be able to write those. So what we're doing here is we're seeing a real live example. It's the word problem that we get in this section of a situation where you want to keep track of what's happening with your money. Well, that's one of the things everybody does. So in finance, Pierre began the year with an unpaid balance of $300 on his credit card. Because he had not read the credit card agreement, he did not realize that the company charged 1.8% interest each month on his unpaid balance. In addition to a $29 penalty in any month he might fail to make a minimum payment, Pierre ignored his credit card bill for 4 consecutive months before finally deciding to pay off the balance. What did he owe after 4 months of non-payment now that his credit is totally ruined? Because it would be. I mean, credit cards, you get a statement, you're supposed to pay at least the minimum balance each time. If you don't do that, immediately they flag you, and you want to make sure you have those paid as quickly as possible. So write a recursive definition. Use a sub o to represent the initial amount so that a sub 1 can represent what he owes after 1 month. Well, what did he owe initially? $300. Now, here's the thing with credit cards. They charge interest daily, not just monthly. So you got a little lucky that they're just having him figure out this interest on a monthly basis. But what we do with those percentages is we have to multiply it by the amount of money he has in the account. But he also owes this initial $300. So he owes the initial 100% plus whatever they're going to charge him each month. And in this example, it said they're going to charge him 1.8%. So he's going to get charged 101.8%. But in a math formula, we always change percentages into decimals. So we would have to move our decimal over twice, and it would be 1.018 times the previous balance. In this case, would be a sub n minus 1. But poor Pierre, he didn't realize he's also getting charged a fee because he didn't pay. What was that fee? $29. So each month, they're taking 1.018 times his previous balance, and then they're going to add that $29 because he didn't pay this. So down here, it says we can use a calculator for this. Basically, we're just using the graphing calculator as an adding machine. Is there anybody that's going to need to borrow one today? Grab some. Anybody else realize we don't have one with? Alrighty, poor Pierre. It says let's enter 300 on the home screen, so I'll just clear everything off and start with 300 and enter, because that was his initial amount. Then enter that recursive formula, 1.018, answer. Well, I've done that a couple of times. That is second negative button. So that basically says take whatever we had before, which is what recursive does, and then we're going to go ahead and add the 29. That's after 1 month. Look at that. $300. All he had in that was $300. That's it. But he didn't pay it. So 1 month later, he has $334.40 that he owes. So now, exactly, that's how credit cards work.
Poor Pierre.
Wait, that's
Poor Pierre. That's 1 month, $29 late fee. So it says press enter 3 more times because we want to know after 4 months when Pierre finally woke up and said, gosh, I better pay this bill. Look at that.
wow, that's what I did press it.
Wow, isn't that something?
So, like I said, we can kind of use, we can kind of use our graphing calculator as an adding machine, is really what we're doing. Now, the ones that accountants use usually will have paper attached to them so that they can, show whoever it is that's needing them to help them with the accounting exactly what they owe. If the credit card company were to allow Pierre to continue making no payments, after how many months would his balance exceed? Remember, he started with $300 in that account, $1,000. That was 4 months. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 months, over $1,000. They would never allow that to happen. I can't imagine that they wouldn't cut off his credit even before the period right now. They would have been calling him after the first month and saying, what's going on, email and texting. Why aren't we getting our money? Because credit card companies, they're loaning you the money. They're not giving it to you and saying, here, it's free. They want their money back. That's 9-1. So 9-1, we identified mathematical patterns. In this one, we're just kind of figuring out, how does all of this work if you have a recursive pattern. And now we're going to go on to 9-2. And thank goodness we start getting some formulas. Because that front page of your packet, if you're wondering what that is for, we're going to start filling that out today. Because any formulas we get, we want on that front page so that later on we can flip back and say, okay, this one was arithmetic, this one was geometric, And this drives me nuts about math. Sometimes things are pronounced old world, and I think it just messes with people's head. To us, this says arithmetic sequences. That makes perfect sense because these are about basic addition. That's what arithmetic is, basic addition. But it's pronounced arithmetic. So, when you look at that and you hear me say arithmetic, know that we're really just talking about arithmetic sequences. And we want to define, identify, and apply some arithmetic sequences today. Arithmetic sequence is a sequence of numbers where the difference between consecutive terms is constant, and it's called the common difference. In fact, just by accident, I'm sure I'm going to call it arithmetic several times, because it's one of the things that I can't stand about math is that sometimes people want to make it sound all big and difficult. It's arithmetic, that's what it is. If you want people to know how to use it, make it easy. But historically, this was called arithmetic. So a sequence of numbers where the difference between consecutive terms is constant. And that constant is called the common difference. Now, why would it be called the common difference if we're always adding the same thing every time? Because to find it, we do a little subtraction in our head. And that's why it's called the common difference. So our sequence is going to look like this. We're going to start with some number A. And basically for us, this will always be a sub 1. And then what we'll do is we'll say, hey, wait a minute, look at that. They're adding something. And that'll be B, our common difference. Well, then to get the next one, they had to add it twice. And to get the next one, they had to add it 3 times. So you're starting with that beginning term. And you notice, hey, they're going up by this much by adding every time. And that makes this arithmetic. So recursive formulas are going to look like this. We're going to have a number that we start with, just like we were doing before. And then we're going to say, all you have to do, because we know this is arithmetic, is take whatever the previous term is and add D, that common difference. And this is going to be where n is greater than 1. We're always going to start with the first term in here, so don't worry too much about that. They're saying that we could have negative terms here. That's more for like a college course where you're dealing with sequences and series. Sometimes you'll play around with n a little bit to try to get something really nice and easy to happen, but not in here. We're going to start with a sub 1. So our explicit formula is going to be, and for us this will always be a sub 1 plus n minus 1 times d. So I'm looking at this and thinking, well, I guess I have to know what n is, and I guess I have to know what d is to make this formula. Well, n is the number of the term, and d is the common difference. Front page of your packet. We just found out what an arithmetic sequence is. So there's our definition right there. That's going to go in the box that says, what's the definition for an arithmetic sequence? And then we have our formulas for recursive, and explicit. So arithmetic sequence is a sequence of numbers where the difference between consecutive terms is constant. This is called the common difference. Looks like everybody has that in there. I'll slide it up so you can see the formulas. All right, so explicit formula, you've got a column there with the arithmetic. And when you have the box, the row for explicit, that's the formula you're going to put in there. And then there's one for recursive. Notice both of these formulas have addition in them. And that's because that's what this formula is for. Basic arithmetic. You're going to add the same amount every time. These formulas can't be used for all of what we did in 9-1. But if we went back, we could find some of them that were arithmetic. And we could use the arithmetic formulas that we have here to write those. So that's what we want to do as we go through this chapter is think, okay, I want as many formulas as I can. So if I went back to 9-1, I'd be able to say, ha, they can't get me this time. I'm seeing this. This is arithmetic. This is geometric. And we can write those formulas. Not all of them are going to work that way. Sometimes we just have to use trial and error. That's just the case with sequences and series. So does anybody need more time to write these formulas? All right, away we go. The first thing we have to do to be able to use these is we have to identify them. We have to say that is an arithmetic sequence. Okay, so in problem 1, I want to see if they are adding the same thing every time. 3 to get 6, 6 to get 9, 9 to get 12, and 12 to get 15. Is that arithmetic? It is. Now let's take it one step further. What were they adding? 3. Now, you might say, I don't get this whole common difference thing, because when I looked at that, I thought, what are they adding? I didn't think subtraction. But technically, remember to undo addition, we're supposed to do subtraction. And that's why it's called the common difference. We're supposed to say, 15 minus 12 is 3, 12 minus 9 is 3, 9 minus 6 is 3, and 6 minus 3 is 3. Now it's the common difference, but it just has to do with inverses. Let's look at B. From 1 to 4, 4 to 9, 9 to 16, 16 to 25. Arithmetic? No. Did you see a pattern?
3, 5, 7, square.
Or the perfect squares. Yeah. So you either see their addition there, they're adding with odd numbers, starting with 3. But it's not arithmetic. That's all we needed to check for. No, it's not working. Not going to be arithmetic. All right, got 2 got it's. Take a second, go through those 2, check in with the chicken wing elbow partner. And if you do find one that you believe is arithmetic, go ahead and write down your D value.
Wait, you like
Has to be just strictly addition. It has to be the same number every time in order to be arithmetic. Check in with somebody. Make sure you're getting the same stuff. Okay, everybody, for A, are we yes or no? No. Adding 2. Adding 4. Adding 8. Is there a pattern? Yes, there's a pattern. It's just not an arithmetic pattern. Is B? Yes. What are they adding each time? So that's the first step. The first step is, hey, I wonder if this is an arithmetic sequence. If it is, then I can use the nice formulas that I have. And that's where we want to get to. We want to get to that point where we can recognize them and use them. That's our objective. So A says, what is the 100th term of the arithmetic sequence that begins 611, ... Now, first off, this is important. They told me what it was. They didn't give me enough terms for me to come to that conclusion on my own. 611, that's not enough of a pattern for me to decide that something is going to be arithmetic. So it's a good thing they told us, yeah, it is. It's arithmetic. Secondly, the first thing that pops in my head is, hey, I've got a formula for that. And I'm not using recursive because they want the 100th term. I'm not going to do recursive. I want explicit. I want to be able to pop a 100 into this formula and say, there it is. There's the 100th term. So now, there's a lot of stuff we need to find. At first it looks that way anyway. But I realize I'm going to be putting a 100 into this later. I'd rather just build a nice formula that would work for any term that they want first, and then put a 100 into it. So what I really need for this formula is I need to know what the first term is, and I need to know what that common difference is. Every time we write these, that's what we want. We want the first term, and we want the common difference. What is the first term? And if you're thinking that's way too easy, it's a 6, it's right there. Yeah, that's what it is. And what are they adding? They're adding 5. So our formula would be a sub n equals 6 plus n minus 1 times 5. Now, you know, this is algebra 2. We're not going to leave it that messy. We're going to go ahead and distribute the 5, even though we're distributing from the right-hand side. We can do that. We're pros. So a sub n equals 6 plus 5n minus 5. And then we're going to simplify by combining like terms. So no matter what number term they want, we can now find it for them. Just so happens they wanted to know the 100th term. So as I'm writing this, I realize, well, I'm replacing n with 100. Because that's what the n stands for. It's what term do you want? So I need to do the same thing over here. And I can get the answer. 500 plus 1 is 501. Didn't even need a calculator. There it is. There's the 100th term. So some of those that were finding formulas like a sub n equals 2n plus 5, it takes a while when you use trial and error. But now we know we can go back and look at those as arithmetic sequences. So B says, what would be the second and third terms of this arithmetic sequence? And I know some of you would be able to figure it out in your head because these numbers aren't that difficult and they're both even. However, we're not supposed to do that. Here's what we're supposed to do. We're supposed to realize that if this is an arithmetic sequence, this is the formula that we need to use. And we need to put in as much information as we possibly can and try to find out what's missing. So let's see. Here's what I know. I know the first term is 100. And I know the fourth term is 82. Now what that just did was it gave me 3 numbers that I can use in this formula. And hopefully that'll help me figure out what that common difference is. So how do I get 3 numbers out of this? Well, this takes up a spot in the formula. A sub 1, it's right here. That's going to work. This 4, anywhere we see an n, that's going to go there. And then this is telling us this is what you get for an answer if you do put a 4 into that formula. So each of those has a spot in this formula. Let's find out where they should go. If we put stuff into this formula, we're going to get 82. The first term is 100. To get that 82, I was looking for the fourth term. Oh, look at that. We only have one variable left. We're going to be able to find that d value. So 82 equals 100 plus 3d. 2-step algebra equation. Subtract 100 from both sides. And divide by 3. And now you can go after it 2 ways. You could say, hey, now I can write the formula because I know what a sub 1 is and I know what d is. Or you could say, well, I know what they're adding every time. So let's see. 100 plus negative 6, that's going to be 94. And then 94 plus negative 6, that's going to be 88. And then try it one more time just to make sure. So 88 plus a negative 6 is 82. Fantastic. We've got it. Those are the numbers that we needed. So you use the formula to go back and find anything that's missing. So now, got it 2a here. It says, what is the 46th term of the arithmetic sequence that begins 3, 5, 7? And I see this. So I am going to call on people today. Let's see what we can do. The first thing I want to know is what formula we should be using to start off with. Oh, let's see. Calista, what was that wonderful formula that we had? Beautiful. We're looking for 2 things to put into this formula. Joey, what are the 2 things we're supposed to put in?
A sub 1 and then, or a sub n. D.
Yeah, you looked at the last one, and this is 2 problems up. Yep. This is always what we want to start with. So, Adam, what should we put in for a sub 1 and d?
A sub 1 is 3 and d is 2.
Hard to find? No. Just look up there and go 3, 5, 7. Oh, they're adding 2 each time. So now let's plug those in here and figure out what to do. So let's see. Allie, what should we do to pretty that up?
Distribute 2.
Sounds like a good plan. And then after we have everything all figured out here, Dylan, what would we have? Now that's more than half the battle. You know, we've created a formula that we could use to find any term, but they didn't want just any term. So Jack, how do I get the 46th term? Did you already get it, Jack? Not yet? Two times 46, 92. 92 plus 1 is 93. Okay, looks good. Well, B has something missing. And we know that's how this always works anyway. We start off with a formula, we start off with a perfect case. We'll always give you a sub 1 and we'll always give you d. No, then they start taking stuff away. So with this one, we know what the first term is, but we don't know what D is. You know, and that's our job. So second and third terms of this arithmetic sequence. Oh, let's see, I need a formula to start off with. Josh, what formula should I use? Same one, right? Now I have to recognize what do I have so I can find D. Hannah, what's that 80 useful for? It sure is. Then they have a 125 up there. Clarissa, what's that 125 supposed to be? A sub 4. Again, we're supposed to realize at this point, we now have 3 numbers that we can put into this formula. 80, a sub 1 is right there. It's part of our formula. And then this 4 needs to go in to get you 125. So we just have to realize where all this stuff goes in the formula. So that's going to be my next question. My next question is going to be, where should we put the 80? Grace, where are we putting the 80? Yeah, silly questions here. Oh, it's right there. That's what it is. So there's the 80. I need to know where to put the 4. Clarissa, where's the 4 going to go? N. And then the 125. Jordan, where are we putting the 125? And of course that leaves us with little d, which is what we wanted to find over there, because we wanted to know what are they adding every time. So simplifying this, we will get 125 equals 80 plus 3. And no, it's not always the 4th term that they give you. You know, they may give you 3 spots in here and give you the 5th term, but just know, use it the exact same way. We'll subtract the 80. And divide by 3. Somebody already have it? I don't want to put anybody in the spot. Already 15.
Yeah.
So now we're not done, but boy did we ever just do the work. I mean, this is the part that takes the most time. But once we have that, well, then we go back up here and say, okay, they started with 80. And what are we supposed to do with the 15? Add it. So what's 80 plus 15? How about 95 plus 15? Add 15 just to be sure. We got it. There they are the middle terms that we needed there. So we use the formula to find D. And like I said, some of you, I'm sure, you looked at that and you did the math right away in your head and you knew what they were going up by. But we can't do that. What we have to do is show our use of the formula. So the more we use it, the better we'll get at it. Now, you know what? You're doing super. You might as well hang on to 3 and what is our schedule this week?
Yeah. Well, let's hang on to it. I think we should hang on to it.
Why are we doing
So I
that?
can,
I agree. Why are we doing 9-1 tomorrow?
I think we
Well,
should hang
because
on
I
to
meant to put that on there for, yeah, that's backwards.
Let's hang on to it.
Let's do that. Let's just stop there.
Yeah.
It'll get a good, we're at a good spot, really good spot.
Yeah.
Yeah.
Yeah. Cool. I don't know if we can do all the
Now, notice I'm not giving you a day 2 assignment from 9-1. And that's because we understand that it's a struggle to write these without formulas. But if we went back, like I said, if we go back later, I want you to recognize, oh, that one's arithmetic. And later we'll learn about geometric. And we'll go back and say, well, now I could do these so much easier. So it was good that we had that little struggle, but we don't need to get frustrated like crazy over sequences and series. There you go. I better fix my schedule over there.
Yeah, we should get some fame time and grass.
Okay.
Really.